Dependent events and probability refer to one event affecting the next event. So for example, you take something out and don't put it back in. Let's say that you have these 10 pieces of candy in a cup. What is the probability that you'll get a blue Jolly Rancher and then a green one if you eat them as you pull them out? So right now we can see that 3 of our 10 pieces of candy are blue. We're going to assume that we got what we wanted, and we're going to eat it, so it's no longer in our count. So now when we find our probability of getting green, we know that 2 out of our remaining 9 are green. We're going to multiply these together. Be sure and cancel a 1 and a 3 here. The 2 and the 10 cancel to a 1 and a 5. Now multiplying across, you get a 1 in 15 chance that you'll get a blue and then a green if you eat them. Let's try another one. What would be the probability of getting 3 red candies in a row if you eat them as you pull them out? So what we're looking for is the probability of red, then red, then red. We have 5 out of our 10 are red. Now we're going to reach in, take one at random. Let's say that we got a red. We're going to eat it. It's no longer in our count. So now when we find our new probability, we're going to see that we have 4 reds left, but only 9 candies. So again, we're going to reach in, we're going to assume we got what we wanted, and now when we find the probability of the third red, we're going to see that there's only 3 remaining red out of only 8 candies. We're going to multiply those probabilities together. Be sure and cancel, so let's reduce this to a 1 and a 2. Let's reduce 4 over 8 to a 1 and a 2. Let's reduce our 3 over 9 to a 1 and a 3. Multiplying across, 1 times 1 times 1 is the numerator, 3 times 2 is 6, times 2 is 12 is the denominator. There's a 1 in 12 chance. Let's review independent and dependent events. If you spin the same spinner twice, that would be considered independent. Flipping a coin 3 times, also independent because one event does not affect the other. If you roll a dice and flip a coin, again, they do not affect each other. How about pick a card from a deck and do not replace it? So when something is not replaced, that's when you know it's a dependent event. If you pick a card from a deck and do replace it though, that's an independent event. If you choose a raffle ticket winner and then choose a second one without putting the first one back in, that would be dependent because the first ticket would no longer be in the cup. Same thing from choosing a block from a cup and not putting it back in because it changes the second event.